2 R3 R4?
Yes.
Yeah, in this scenario, which router will become DR?
4.4 R4.
Router 4 DR. And which router will generate LSA2? Which router will generate LSA1? All routers?
LS1 generate all routers.
All router will generate LSA1? Yes or no? Let's say I am
Yes.
talking about LSA1 of router 1. What will be the information inside LSA1 of router 1? Router ID?
Router ID and LS.
LSA1 of
uh,
router, let's say 4. Router 4. Router ID will be there like 4.4.4.4. Then
Back to link state.
link ID will be there.
ID.
Link ID in the LSA header 1.1.1, and inside the LSA there will be link information like there is one link 1, and on this link which network is running like 192.168.1.0/24 network is running, right? Okay, this is LSA1 of router 4. Now tell me inside the LSA2, LSA2 router 4 will also generate LSA2, right? Because router 2 is DR. It will generate LSA2 also. LSA2 of router 4. What will be the information inside this LSA2? What will be the router ID? Router ID of router means 4.4.4. And what will be the link ID here? This is question. What will be the link ID inside LSA2 of router 4? Means network LSA.
192.168.
Yes, very good. IP address of DR router. Network LSA. IP address of DR that will be 192.168.1.4. I am talking about previous scenario. In last class, we discussed this scenario. Router 4, this is IP address of router 4. And then inside, this is the header. And inside the LSA2, what will be the information? Attached router, right? Attached router. Attached router means 4.4.4 and 1.1.1, 3.3.3 and 2.2.2. Yes or no?
Jay, can you please start that recording?
Yeah, recording is on, brother. Correct.
Okay, thank you.
Yesterday we discussed this. This is LSA1, this is LSA2. And today our concern is to understand LSA3. And to understand LSA3, first we need to discuss types of router in OSPF. Guys, in OSPF we have different types of router. Let me talk about that. Then we will come to LSA3. Okay, so type of router, heading is topic for the day is types of router in OSPF. How many types of router are there, guys? Four. Four type of routers are there in OSPF. First one is internal router. Internal router, or you can say backbone router. Second type of router is first one is this is second type of router. Internal router is second type of router. First type of router is backbone router. Backbone router. And third type of router is
ABR.
ABR router. And fourth type of router is
ASBR.
ASBR router. See, router whose all interface belongs to area 0, that type of router is called backbone router. Router whose all interface belongs to area 0. Router whose all interface belongs to any other area except area 0. Router whose all interfaces belongs to any other area except area 0. That type of router is known as internal router, ABR router. Router whose at least one interface belongs to area 0 and at least one interface belongs to any regular area. See, generally there are two types of area in OSPF. First one is regular area, first one is backbone area, and second one is regular area. Area 0 is called backbone area. Area 0 is called backbone area, and except area 0, all areas are called regular area. This is area 0. Area 0 is called backbone area, and all the area except area 0 is known as regular area, like area 1, area 2, all areas except area 0 is called regular area, like area 10, area 100, area 200, area 1, 2, 3, 4, 5, any area except area 0 is known as regular area. So the router whose at least one interface belongs to area 0 means backbone area, and at least one interface belongs to any regular area, that type of router is known as ABR router. And ASBR router is router whose at least one interface belongs to OSPF domain and at least one interface belongs to any other routing domain, means on the router where we will perform redistribution. So that router will become ASBR router. ASBR router means this router have one interface, at least one interface in OSPF domain and one interface in different routing domain. Fine. So like if I will draw one diagram here, let's say here I have some router 1, router 2, router 3, router let's say 4, 5, 6, 7, 8, and let's say 9. Okay, let's say this is R1, this is R2, this is R3, this is R4, this is R5, this is R6, this is R7, this is R8, this is let's say R9. Fine, all routers are directly connected with each other like this. And here in this scenario, let's say this is my area 0. Here we are running OSPF area 0. These two interface of router 4 belongs to area 0, and this is, let's say this is let's say area 1, any regular area, and here we are running let's say any here we are running let's say EIGRP. This is different domain, right? So now this is my area 0, this is area 0, area 0, this is area 1, this is area, let's say this is EIGRP domain. Here we are running any other routing protocol. So in this scenario guys, R1, see, all interface of router 1 belongs to which area? This interface also and this interface also. In which area? In area 0. That means router 1 is which type of router?
Backbone.
Backbone router.
Router whose all interface belongs to area 0. Router 2 is also which type of router?
Backbone router.
Backbone router, because see, both interface belongs to area 0. Router 3 is also backbone router. But router 4?
ABR.
ABR, because two interface of router 4 belongs to area 0 and one interface belongs to area 1. As I told you, router whose at least one interface belongs to area 0 and at least one interface belongs to any other regular area, that type of router is ABR router. So in this scenario, router 4 is my ABR router, right? Router 5, which type of router it is? all interface of router 5 belongs to which area? Area 1 means regular area. So this
Internal.
is internal router. Router whose all interface belongs to regular area means in any area except area 0. And if I will talk about router number 6, so one interface of router 6 belongs to OSPF domain in area 1 and one interface belongs to EAGRP domain. So this router is known as
ASBR.
ESBR router. ESBR router, right? This
Mr.
router is also ESBR router. Yes.
Someone is waiting at lobby, I think. Can you please allow him?
Somnath. Fine. So is it clear, guys? Types of router in OSPF. Now you can find which type of router it is, like in OSPF domain. Router 1 is which type of router, router 2 is which type of router, router 4 is which type of router, like this. And as I told you, between area, OSPF is not a link state routing protocol. OSPF is not a link state routing protocol. See what will happen. Let's say here R1 is connected with one network 10/8. 10.0.0.0/8 is directly connected with router number 1. How router 1 will share this network information to their neighbor, means to router number 2 and router number 3, in the form of which LSA? In the form of which LSA?
Could you please repeat the question once again?
How router is advertising link information to their neighbor in OSPF? Router 1 have one network that is 10.0.0.0/8. Router 1 will advertise it to router number 2. So in the form of which LSA router 1 will advertise it to router 2? Guys,
Sending the hello message, LSA1.
hello message.
Hello
Hello. Hello message is not to share in prefix information, brother. Router 1 will generate their LSA1. Inside the LSA1 there will be link information. So router 1 will send LSA1 to their neighbor, to router 2 also and to router number 3 also. In this LSA1 there will be information of this network, and router 2 will advertise that LSA1 to router 4, and router 3 will also advertise it to router number 4. But LSA1 cannot cross area. Router LSA means LSA1 flooded within AS. Within AS. Area. LSA1 cannot cross area. Right? Then how router 5 will get this network information? Getting my point? Or let's say router 5 have one network that is 50.1.1.0/24. Router 5 will share their LSA1 to router number 4, but LSA1 cannot cross area. So how router 2, router 2, router 3 and router 1 will get this 50 network information? Yes or no? So that's why we have what? LSA3, that is summary LSA. ABR router will generate LSA3 to share inter-area prefixes. Like router 4 will generate in this scenario 2 number of LSA3, one for area 0 and one for area 1. Correct? In fact, router will generate how many number of LSA3 in area 0? So it depends on the number of network in area 1. How many network are there in area 1? So one network is this one network is this one network is this one, and one network is this one. That means router 4 will generate how many number of LSA3? 4 number of LSA3 in area 0. In area 1, 1, 2, 3, 4 and 5. 5 number of LSA3 it will generate for area 1. Just guys 1 minute. 3 and why?
R4, ABR router.
ABR router. Why?
It is cross the area, not within the area. It is
To
connected
share
the
inter-area prefixes. Because LSA1 cannot cross area, that's why ABR router will generate LSA3 to share inter-area prefixes. So here router 4, router 1 will learn only 50 prefixes, right? It will not learn detailed information of router number 5. router 1 don't know detailed information of router 5. Means router 3, router 4 will generate ABR, LSA3 to share prefixes directly, prefixes only. Like LSA1 carry detailed information of link, but LSA3 will carry only prefix information like EIGRP update message. Done. So that's why OSPF is not link state routing protocol between areas. Between area, again we are exchanging prefixes like EIGRP. Within area, we are exchanging LSA1 detailed information of router. By checking their LSA1 information, router can design entire topology. But within area. Fine. Is it clear? Now we will see a small practical of it, LSA3. Then we will move further. So let me check, is there any lab pre-configured? Area 10, area 0, area 20, and EIGRP. So yes, we can use this lab also, or I can, it will be better if I will create another lab in GNS3 easy lab. Leave it for now. Till now we discussed three types of LSA: LSA1, LSA2, LSA3. LSA1 is router LSA, LSA2 is network LSA, LSA3 is summary LSA. All router will generate LSA1, but LSA1 cannot cross area. DR router will generate LSA2 to share, let me repeat. All router in OSPF domain will generate LSA1 to share link information to their neighbor, but LSA1 cannot cross area. In broadcast network, DR router will generate LSA2 to share directly connected router information to DR other, and ABR router will generate LSA3 to share inter-area prefixes, right? So hope this is clear to everyone. Now here I am going to perform on lab of ABR first. Router 1, 2, 3, let's say 4. Here we have switches. And guys, you guys should ask one question here. That question should be this one. Question should be this one. Like in this scenario, how router 1 will came to know that router 4 is ABR router? This should be your question. Or how router 5 will came to know that router 4 is my ABR router? So what ABR router will do? Actually, you know, in LSA1 we have 3 flag. In LSA1 we have 3 flag. First one is B bit flag, B bit flag. Second one is E bit flag, and third one is V bit flag, V bit. So we will discuss V bit later, it is not important, but B bit and E bit is important. Whenever ABR router will share their LSA1, it will on B bit in their LSA1. By default, all routers send LSA1 with this bit off. But ABR router will send B bits on LSA1. So whenever router 1 will receive LSA1 of router 4 with B bit on, it will came to know that router 4 is ABR router, right? And ASBR router will send E bit on LSA, right? So we will discuss about that also. First of all, let me configure the scenario. In this scenario, this is my, let's say, area 0. This is area 0, or this is area 0, and this is area 1, or any regular area, let's say area 10. Here we are running one network 10.1.1.0/24, and here also we are running one network, that is 40.1.1.0/24, and between router I am going to use same network. Like here, this is area 0, and this is my area 1. So in this scenario, router 1 is which type of router?
Backbone router.
Router 2,
Backbone.
router 3,
ABR.
router
ABR.
4.
Internal
Internal
router.
router.
Very good. Config T, interface fast Ethernet 0/0, no set. This is update message. This is link state packet. Here we have LSA1. Inside this LSA1, we can see the flag section. Okay. Flag is here. Inside the flag, VBIT is off. By default, all router send LSA1 with this bit off. E bit is also off. V bit is also off. And these three are not in our syllabus. Fine. Now here we have neighborship also between router 2 and router 1. Now let me configure R3. R3 console is missing. Config T, interface fast Ethernet 0/0, no set. IP address 23.1.1.3. 34.1.1.3 255.255.255.0 exit. This time interface fast Ethernet 0/0 IP OSPF 1 area 0 and interface fast Ethernet 1/0 IP OSPF which area?
Area 1.
Area 1. Very good. And now in the capturing, if you will see LSA1 of router 3, advertiser router ID is router 2. I am looking for LSA1 of router 3. So router ID should be 3.3.3. Fine. This is LSA3. Let me check here one thing. Oh, on R3 router ID is not 3.3.3. Let me do one thing. Router OSPF 1 router ID 3.3.3.3 clear IP OSPF process, say yes. Or here also we can see in this update message, I think router ID was source router ID is this one. This is LSA3. Inside the LSA3 we have some prefix information, that is fine. I have to capture link between router 2 and router 3, I think. Then we can see that LSA1 of router 3, where it is. If you will see LSA1 of router 3 here, it is sending V bit on LSA1. Wait, I will show you here also. I think I can check it on router number 1. So IP OSPF database. Inside the database there is router LSA of 3.3.3. Yes, with sequence number 2. If I will open this in detail, router 3.3.3.3, here we cannot see bits. No, flag is not there. Okay, I will show it later. But on router number 1 we can run one command to check ABR router. So IP OSPF border router. This command will show you which router is border router. And here we are able to see router 3 means 3.3.3.3 is border router. Reachable via 12.1.1.2 on which interface on fast Ethernet 1/0 is ABR router. And on router number 3 I can run show IP protocol command. In show IP protocol command we can see it is an area border router. And on router number 1, if you will check, one more thing, routing table. So IP route OSPF. So inside the routing table you can see we have prefix with two different symbol. One is with O symbol, that is 23.1.1.0, this network which is running between router 2 and router 3, and one is 34 network which is running between router 3 and router 4. Means ABR is sending this network information to R1, right? So it have learned this prefix through this symbol OIA. OIA means inter area prefix, means this prefix belongs to different area. Here you can see O means OSPF prefix, means same area, intra area prefix, and IA means OSPF inter-area prefix. So this is OSPF inter-area prefix. This is OSPF intra-area prefix. This means router 1 have learned this prefix in the form of LSA1 and router 1 have learned this prefix in the form of LSA. Which LSA?
3.
3. Right? And let me configure R4 also here. Interface fast Ethernet 1/0. IP address is 34.1.1.4.255.255.255.0 exit. Interface fast Ethernet 0/0 no set, and IP address is 40.1.1.1 255.255.255.0 exit. Router OSPF1 router ID 4.4.4.4 exit. Interface range F 0/0 and F 1/0. IP OSPF process 1 area 1. Before running this command, let me capture the link between router 3 and router 4. I'm stopping this capturing here, not required, and let me capture this link. Fine. And now I am going to hit enter. First, both router will become neighbor by sending hello message. After that, both router will exchange DBD. First empty DBD in X start state, then header DBD with header in exchange state, then LSR, LSU and LSAC. So we will see the update message which router 3 is sending to router 4. You will see it is sending LSA1 with B bit on. Here we don't have neighborship. What happened? Do so IP interface brief exclude unassign. Do so IP. So this interface is administratively done. Interface fast Ethernet 1/0 say no set. Soon OSPF neighbor will come up. Yes. And now see this update message. Which router is sending? 4.4.4. Source router ID is 4.4.4. Which router is sending this LSA? Router 1, router 3, 3.3.3. If you will open this LSA update message, you can see inside the update message there are some LSA1. If you will open this LSA1, you can check the flag field. B bit is on. Why router 3 is sending B bit on LSA1? Because router 3 is ABR. Why? Because it has one interface in area 1 and one interface in area 0. Fine. And on router number 3 or on router number 4, on router number 1 also, let me show you router 1 database. Inside the R1 database, so IP OSPF database. Okay, first of all, we have some network LSA, right? But guys, tell me, in this scenario, DR and BDR is required or not? By your existing knowledge, tell me. Yesterday we understood in which scenario we need DR and BDR. When we have multiple router in same segment. But here between routers, like between router 1 and router 2, we don't need DR and BDR. Here we can't reduce number of adjacency or number of flooding, because this is point-to-point connection. But by default, as I told you, on DR and BDR election depends on OSPF network type, guys. And by default, OSPF network type on Ethernet link is broadcast. And on broadcast network type, router always perform DR and BDR election. So here I should change network type manually. Whenever we are using Ethernet link between two router, we should change network type every time for faster convergence, so that DR and BDR election will not happen there, because DR and BDR is not required here, right? So you can see, so IP So IP OSPF interface fast Ethernet 1/0. Fast Ethernet 1/0. Here you can see the network type. Network type is what? Broadcast. Network type is broadcast, but here network type should be point to point because this is point to point link. So manually here I should change network type. Go to interface fast Ethernet 1/0 and IP OSPF network. What we can say? Point to point. And if here network type is point to point and here network type is broadcast, again this is parameter of OSPF. Note in neighborship, neighborship is still there, but now routers will not exchange database. If network type will be mismatch, router can't exchange database. Fine. So now router 1 here on fast Ethernet 1/0 of router 1 network type is so IP OSPF interface fast Ethernet 1/0. Here network type is what? Point to point. And on router number 2 fast Ethernet 0/0. So IP OSPF interface fast Ethernet 0/0. Network type is broadcast. Right. So network type should be match. Then only router will exchange database. So like now if you will check database of router 1, so IP OSPF database, inside the database clear IP OSPF database, clear IP OSPF process, and so IP OSPF database, so IP route OSPF C. Still okay, inside the database LSAs are there of router 2, but router have not installed any prefixes in their routing table.
What about
Router
membership? What
neighborship
about
is still there, so IP OSPF neighbor, neighborship is there, that's why it is exchanging database. So IP OSPF neighborship is full, there is no DR and BDR. But on router number 2, so IP OSPF neighbor, here it's saying router 1 is BDR, right? So on router number 2 also we should change network type, like on fast Ethernet 0/0 I am going to say IP OSPF network point to point. And now you can check routing table of R1, so IP route OSPF, now we have prefixes inside the routing table, correct? And neighborship is there, so IP OSPF neighbor, right? Now you can see here DR and BDR is not required on router number 2 also, so IP OSPF, so IP OSPF neighbor. Fine. Guys, sometimes people are doing one mistake here. What? Like between router 1 and router 2 we don't need DR and BDR, right? So you should change network type, not priority. If you are thinking that if I will configure priority 0 on both sides, right, DR BDR election will not happen because router will not participate in DR and BDR. But network type is still what? Broadcast. So DR and BDR is required, but there is no any DR and BDR, then neighborship will not come up. Okay, so you will not set priority 0 there, you can't set it priority 0, you should change network type, right? And in the same way this interface fast Ethernet 1/0 also interface fast Ethernet 1/0 IP OSPF network point to point. On R3 also interface range fast Ethernet 0/0 and fast Ethernet 1/0 IP OSPF network point to point. And finally on R4 interface fast Ethernet 1/0 IP OSPF network point to point. Fine. Now if you will check again database of router 1, see the database of router 1 now, so IP OSPF database. Now we don't have LSA2 because there is no DR and BDR. Now we have some LSA1 and we have some LSA3. How many LSA1 are there? 3. Why? Because we have 3 router in area 0, right? We don't have any LSA1 of area 1 of router 4, correct guys? And how many LSA3 we have on router number 1? 2. Why? Because there are 2 number of network in area 1. See, it is sending this network 34.1.1.0 and 40.1.1.0 network. Advertiser router is 3.3.3. Who is advertising this network? Router 3. So advertiser router ID will be the router ID of ABR router, and link ID will be the prefix information. Link ID will be the prefix information in LSA3. As I told you, all LSAs will carry these two information, advertiser router ID and link ID. So in LSA3, link ID will be prefix information. In LSA2, link ID will be DR IP address. In LSA1, link ID will be the router ID of router who is advertising the LSA. Means advertising ID and link ID will be same in LSA1. Is it clear till here? Any question? No?
Can you configure priority 0 and show the neighborship will break?
Yes, sure. What we can do, first of all, on interface fast ethernet 1/0, again I am going to configure IP OSPF network broadcast, that is default, and on router number 2 interface fast ethernet 0/0 IP OSPF network point to point. Now you can see R1 database, so IP OSPF database, we have LSA2. Just wait for some time, neighborship will come up. So IP OSPF neighborship is in two-way state. Here DR and BDR election will happen. One router will become DR, one router will become BDR. Election timer is DR and BDR election timer is, guys, 40 seconds.
Second.
Yes. Access start full. Now so IP OSPF database. Inside the database, so IP OSPF neighbor, which router is DR, router 2 is DR. So IP OSPF database, inside the database there should be one LSA2 also. Just wait. So IP OSPF database, why we don't have LSA2?
Both routers have different type. One is broadcast, one is point to point you selected.
So IP OSPF interface fast ethernet 0/0 include network type. Here network type is broadcast.
The R2 also.
Here network type is point to point. Interface fast ethernet 0/0 IP OSPF network broadcast. And so IP OSPF neighbor, access start, and so IP OSPF database, router LSA. Okay, so IP OSPF database. Now we have LSA2. Now to avoid DR and VDR between router 1 and router 2, if we will change priority, then see what will happen. If I will set priority here, interface fast ethernet 1/0 IP OSPF priority 0, and on router number 2 also config T, interface fast ethernet 0/0 IP OSPF priority 0. Now these two router will not participate in DR and VDR election, but network type is broadcast, so DR and VDR is required. Clear IP OSPF process? Yes. So IP OSPF neighbor. So IP OSPF interface fast Ethernet 0/0. Fine. So if DR and BDR election will not happen in OSPF network type broadcast, in broadcast network type, the neighbors will stuck in which state?
Extra
Huh? Why, brother? DR BDR election happened in two-way state.
two-way. Okay.
Yes, two-way.
Fine. Here state is DR router 2. So IP OSPF interface fast Ethernet 0/0. Here state is
DR other.
DR other. Here also state should be DR other. So IP OSPF database, that is fine. So IP OSPF neighbor, that is fine. DR other and router 2. So IP OSPF neighbor with 1.1.1. 1.1.1 is DR other. This is wrong information. So IP OSPF interface fast Ethernet 0/0. This is incorrect. State should be DR other here, and neighbors will stuck in two-way state. These routers are not going to exchange any database. Fine. So we cannot set priority 0 to avoid DR and VDR in network type broadcast. Fine. Again, I am going to correct it. Interface fast Ethernet 1/0 and IP OSPF network point to point. On router number 2 also interface fast Ethernet 0/0 IP OSPF network point to point.
In
And so
real
IP
environment also, we have to.
chain network type point to point.
That is only one way, na? Is there any
Yes.
other way?
No.
No. Okay.
You have to change. Whenever you are using Ethernet link between router, first things that you should configure in OSPF is network type. Before enabling OSPF, it should be like habit. Like on before running router OSPF1 router ID, this command I should run interface fast Ethernet 0/0 IP address 12.1.1.1 255.255.255.0 IP OSPF network point to point, right? Then no set. This should be the configuration of WAN link. Fine. Now on router number 1, so IP OSPF database, we have 3 number of LSA1, right? Because we have 3 number of router in area 0 and we have 2 number of LSA2. On router number 4, so IP OSPF database. Guys, inside the database of router number 4, how many LSA1 will be there? How many LSA1 will be there inside the database of R4?
3.
Oh my god. Why 3?
2 only.
R3 and R4, I think.
Yes, 2 na, because there are 2 routers in area 1. So all routers generate LSA1 and LSA1 cannot cross area, means area 1. In area 1 there are 2 routers. So both routers will have 2 number of LSA1, one of router 3, one of router 4. And how many LSA3 will be there?
That is 3. R1, R2,
3.
R3.
R1, R2, R3? No.
No?
See, for that we can do one thing. On R3 we can check so IP OSPF database. How many? See the database of R3. R3 have some LSA1 in area 0 and it have some LSA1 in area 1, right? 3 LSA in area 0 and 2 LSA1 in area 1. So it will generate 3 number of in area 1 in area 0. So IP route OSPF. So this is routing table of R3. See, R3 have learned 10 network, 10.1.1.0, 12 network and 40 network. Fine. These two network belongs to which area?
Area 0.
These two
Area
network
0.
area 0, right? And this network belongs to which area?
Area 1.
1.
Area 1. So R3 need to share this network in area 0 and these two network in which area? In area 1, right? Means how many total number of network in area 0? One is this network, one is this network and one is this network. 3 number of network are there. So R3 will generate 3 number of LSA3 to their neighbor. And for this area, how many LSA3 router 3 will generate? How many LSA3 router 3 will generate? How many prefixes are there in area 1?
2.
1,
2.
2. So it will generate 2 number of LSA2.
3.
Sorry, LSA3. And inside the LSA3, router ID will be the router ID of router who is advertising that LSA, and link ID will be prefix information, network information. Like link 1 will be network which is running here, link 2 will be this network. Inside this LSA, link 1 will be this network, link 2 this, link 3 this, right? So here we are able to see same information on router number 4. We can see the database. So IPOSPF database, we have 3 number of LSA3 and link ID is 10.1.1.0, one network, 12.1.1.0 and 23.1.1.0. Advertiser router ID is 3.3.3. Correct? These two are LSA1. This is LSA1 of router 3. This is LSA1 of router 4. Right? And so IP route OSPF. In the routing table, we are able to see 10 prefix, correct? 10.1.1.0/24. And what is the cost, guys? Cost is
4.
4.
4. How? Cost of this link is? Cost of this link is 1.
1.
Cost of this link is 1.
Faster.
Cost of this link is 1. Cost of this link is
1.
1. So total cost is 4. Question is how router 4 calculate this cost? 4. Actually, router 4 have checked that I have received this network from which router. So IPOSPF database. I have received 10.1.1.0/24 from router number 3 in the form of which LSA? In the form of LSA3. And which router generate LSA3? ABR router. So it will check ABR. So IP OSPF border router. Border router. And what is the cost to reach border router? Border router is 3.3.3 and cost is
1.
1. And so IP OSPF database and then summary LSA of 3.3.3.3, or here we can say link ID, that is 10.1.1.0. What is the cost coming in LSA3? What is the cost coming in LSA3? 3. And cost to reach AVR from me is
1.
1. That means total cost to reach this destination is
4.
4. Right? Like this, router 1. So IP route OSPF. Router 1 have also learned this 40 network. And what is cost? Cost is 4. How? So IP OSPF data. So IP OSPF database and then summary LSA of 40.1.1.0. What is the cost coming in LSA3? 2. And what is the cost to reach? Cost to reach ABR router who is generating this LSA. Who is generating? Advertiser router is 3.3.3. So cost to reach 3.3.3 is, so IP OSPF border, so IP OSPF border router. Cost to reach ABR is 2. So total cost to reach 40 network is what? 2 plus 2 means cost to reach ABR is 2 and ABR is generating a prefix with cost what? 2. So total cost to reach destination is 4. That's why it have installed this network in their routing table with cost what? 4. Fine. And now it can ping also, ping 40.1.1.1, source is 10.1.1.1. Ping is working. Fine. So any question guys in LSA3? Which router will generate, why it will generate, right? What will be the link ID, what will be the router ID, advertise the router ID inside the LSA3? Any question in this thing?
Can we configure multiple ABR routers for the same scenario?
Yes, we will configure it later on. We will configure multiple ABR also, don't worry. We have one topology here guys. See, in this topology, where is OSPF? I will configure this scenario. In this scenario, how many ABR is there? Area, this is area 0, this is area 10. Router 4 and router 5 is? Both
ABR.
router are ABR, na? Yes.
Yes.
So later on I will configure this scenario, right? Don't worry about that. We will have multiple, what we say, ABR, multiple ASBR. Fine. So now, till now we discussed three type of LSA: LSA1, LSA2, LSA3. Guys, I am telling you one technique to remember LSA, that use of LSA, you can say. See, LSA1 is used to share network information, definitely yes, because it carry detailed information of link. So it carry prefix information, it is used to share network information. If I will talk about LSA2, LSA2. So LSA2 is not used to share network information, right? It is used to share directly connected router in broadcast network. Then LSA3. Again, LSA3 is used to share network information, correct? In the form of LSA3, router are sending inter-area prefixes, network information. Again, if I will talk about LSA4, so LSA4 is not used to share network information. All odd number LSA is used to share network information, and all even number LSA is used to share some extra information, other information except network information. Even number LSAs are not used to share network information. Fine. Like LSA2, DR router will generate LSA2 to share directly connected router, and LSA4. Which router will generate LSA4? ABR router. To share just information about ESBR. That who is ESBR? Who is ESBR? And again LSA5. LSA5 is used to share external prefixes in OSPF domain. LSA5. So again, this is odd number LSA. It is used to share network information. So always keep in mind, all odd number LSAs are used to share prefix information, and even number LSAs are used to share information about router, information of router. Fine. Now let's say this router 4 is connected with one another router here, R5. R5, and this interface of router 4 is connected with router number 5, and here we are running any other routing protocol. Let's say router 4 is also connected, router 5 is connected with one network. This is my, let's say, EAGRP domain. Here we are running EAGRP, and router 4 have one LAN 50.1.1.0/24. This is my EAGRP domain. So in this scenario, which router is ASBR router?
R4.
R4, because R4 have one interface in OSPF domain and one interface in EAGRP domain. First of all, let me configure this scenario. Interface fast Ethernet 1/1 1/1 no set IP address 45.1.1.4 255.255.255.0 exit router EAGRP AS number, let's say 10, and network 45.1.1.0 done, and say no auto summary also. Fine. Now sorry, I have configured R5 here, so let me remove it. No router EAGRP AS number 10 interface fast Ethernet 0/0 no set IP address is 45.1.1.5 255.255.255.0 IP address is overlapping interface fast Ethernet 1/1 IP address is 50.1.1.1 255.255.255.0 exit interface fast Ethernet 0/0, and here I am going to configure this IP. Done. And then router EAGRP as number 10, let's say network 0.0.0. I have run network 0.0.0 command. I have advertised all interfaces in EAGRP. Then on router number 4, interface fast Ethernet 1/1 no set IP address is 45.1.1.4 255.255.255.0, correct. And then a router EAGRP as number 10 network 45.1.1.0 0.0.0.255. Then soon EAGRP neighborship will come up. Here you can see, and so IP route EAGRP, this router is now receiving this prefix 50.1.1.0/24. This is metric and ID value. Fine. Now how router 4 will tell to router number 3 that I am ASBR. So as I told you that there is one E bit in LSA1. It will on E bit in their LSA1. So router 3 will came to know that okay, router 4 is ASBR. But router 3 will not forward that LSA1 to router number 2 in different area. Then how router 2 and router 1 will came to know about ASBR? Because if router 1 and router 2 don't know about ASBR, what is the cost to reach ASBR, it cannot calculate metric for external prefixes. Like router 1 cannot calculate metric for 40 network until and unless router 1 don't know who is my ABR and what is cost to reach ABR, who is advertising it, what is the cost from me to ABR router, then only I can calculate total cost. So router 1 and router 2 will never came to know about ESBR router because LSA1 cannot cross the area, right? So router 3 know who is ASBR, but router 2, router 1 don't know. So in this scenario, what router 3 will do? Router 3 will generate one separate LSA, that is LSA4, ASBR summary LSA, and that LSA will carry ASBR information. That LSA will carry ASBR information, so that router 2 and router 1 can get who is ASBR router. See, first of all, on router number 4, I have to redistribute, then only it will redistribute the 50 prefixes into OSPF domain. So let me do one thing here, router OSPF process 1 and redistribute EAGRP AS number 10 and subnet. Now let me check R1 routing table. So IP route OSPF, yes, it have not received 50 prefixes till now. Just wait. Yes, it have received 50 prefix 50.1.1.0. And what is the metric? 20. Reachable via 12.1.1.2. And here we are able to see symbol is different now. OE2. OE2 2. And let me run one more command on router number 4. Later on we will discuss that also. Router OSPF 1 and redistribute subnet matrix type 1. Now on router number 1 you can see cost is 23. Fine. And so IP OSPF database. Inside the database now we are able to see two new LSA. One is summary ASBR LSA, that is LSA4, and second one is type 5 LSA, that is external LSA, right? Type 5 LSA carry network information. Inside the link ID you can see 45.1.1.0 and 50.1.1.0, right? Who is advertising it? Router number 4, 4.4.4. ASBR router is advertising LSA5, and with the help of LSA5 it is sharing external prefixes, EIGRP prefixes in OSPF domain. And this LSA, LSA4, you can see carry only the information of ASBR. Link ID is ID of ASBR, router ID of ASBR, and advertiser router ID is 3.3.3 ABR. Who is advertising it? Who is advertising it? ABR router. And link ID will be the ID of router ID of ASBR router. Now if I will open this LSA in detail, or here we can run this command, so IPOSPF border router also to check. Now you can see router 3.3.3 is ABR router, ABR, and 4.4.4 is ASBR, ASBR. And what is the cost to reach ASBR? 3. And what is the cost to reach ABR? 2. Now if I will open any LSA 5, so IP OSPF database, because I want to calculate cost to reach in 50 network, 50.1.1.0/24 network. So I will check router 4 is advertising this network with what cost. So IP OSPF database and then external 50.1.1.0. What is cost here? Metric is 20. And what is the cost to reach ASBR? So IP OSPF border router 3. Total cost for 50 network will be what?
23.
So IP dot OSPF 23. Okay. So LSA1, all router in OSPF domain will generate LSA1, but LSA1 cannot cross area, and LSA1 carry link information. DR router will generate LSA2 to share directly connected router in broadcast network. ABR router will generate LSA3 to share inter-area prefixes. ABR router will generate LSA4 to share ASBR information, and ASBR router will generate LSA5 to share external prefixes. Any doubt in this? Any doubt in this, guys? Any doubt till here? Anybody? Okay, tell me, let me ask some question. When router 4 will generate their LSA1, router 4 will on which bit? Router 4 will on which bit?
E bit.
Yes. E bit?
Yes.
Yes. And when router 3 will generate their LSA1, it will on which bit?
P bit.
B bit, na?
Mm.
B bit. And router 1 will generate how many LSA?
LSA1
Only LSA1?
and LSA1, LSA3.
LSA3. Router 1 is not ABR, brother.
LSA1 only.
LSA1. Router 2?
LSA1 only.
Router 3?
LSA1, LSA3.
LSA1, LSA3 and
LSA5.
5,
LSA4.
not
4.
5.
4.
4, na? To share ESBR information. Router 4?
1.
Okay.
1, 4, 5.
Not 4. ABR router will generate 4. Only ABR rotor will generate LSA4.
I think 135.
3, not 3, brother. ABR rotor will generate LSA3 and LSA4. LSA1 and LSA5.
1 and
See na here also. So IP OSPF database. Router 4 is advertising how many LSA? Here we are able to see LSA5 from 4.4.4 only, right? And in router number 4 here we can check. So IP OSPF database. Router 4 is generating LSA5 and LSA1 only. Router 3 is generating LSA3, not router 4. ASBR router will generate two types of LSA, LSA5 and
1.
LSA1, right? So which router is generating three number of LSA?
ABR router.
ABR. LSA1, LSA3 and LSA4.
4.
And LSA5. Can LSA5 cross area?
Yes.
Yes. That's why we are able to see LSA5 of router 4 on router number 1. Can LSA3 cross area?
Yes.
Yes. Can LSA4 cross area? Yes. Can LSA1 cross area?
No.
Okay.
Can LSA2 cross area?
No.
No, LSA2 cannot cross area. In fact, LSA2 cannot cross subnet also, you can say, broadcast domain. Like here, let's say network type is network type. So let's say router 2 is DR router. Here router 2 is DR router. Here router between router 3 and router 4, router 3 is let's say DR. So in this segment, we will have one DR. One router will generate LSA2, and that LSA2 will not receive by router number 1. Router 1 will not receive LSA2 of this link between router 2 and router 3. Inside the router 1 database, we will see how many LSA2? Only one. Router 1. Here on router number 2, how many LSA2 will be there?
1.
1 or 2?
1 and 2. R1 and R2. 2.
2 na?
2.
One of this link and one of this link. Okay. Can I move?
If
Now
we
next
subnet
concept,
will
yeah.
not match, subnet will not match for this scenario in this OSPF, is there any possibility to get the form the OSPF
If
neighbor
subnet will not match, neighborship will not come up.
not
This is
come?
neighborship parameter.
Okay. For EAGRP, we placed some router. It is not in the same subnet.
No, in AIGRP also subnet should be same.
Okay. If R5 router having the different subnet, R4 having
Neighborship will
the,
not come up.
okay, got it. Why it is the one type of this thing, why subnet should match, any specific reason?
If subnet will not match, router 1 cannot communicate with router 2. Now we have type of area in OSPF. This concept. Let me do one thing. Here guys, in this scenario, how many backbone routers are there?
1 area 0.
Only one backbone router are there, or there is no backbone router. Is there any backbone router
I
in
think
this
all
scenario?
area 0 all routers we are think no,
No, there is no backbone router.
no backbone.
Both are ABR.
Both are area.
Okay. Now let me ask one question here to you. I have router 1 here, R1, connected with R2, connected with R3, connected with R4. Here I have one loopback 10.1.1.1. Here I have one loopback 40.1.1.1. And this is in area 1 and this is in area 2. Area 2. Can 10.1.1 ping 40.1.1.2?
No,
Why?
no backbone area. All areas should be connected to the backbone area.
Two regular area cannot communicate with each other. Reason? See, when router 1 will generate their LSA1, it will forward their LSA1 to router number 2, and inside that LSA there will be this network information 10.1.1.1, and router 2 will not forward that LSA1 to router number 3, because this time router 2 cannot generate LSA3 because router 3 is not ABR router. Getting my point? Router 2 will not forward LSA1 of router 1 to router number 3, and it will not generate any LSA3 to share inter-area prefixes. In the same way, router 4 will share their LSA1 to router number 3, router 3 will share that LSA1 to router number 2, but router 2 will not forward that LSA1 to router number 1. LSA1 cannot cross area, and this time this router is not ABR router, it will not generate any LSA3 to share inter-area prefixes. So router 1 will never get this 40 network and router 4 will never get 10 network. So always keep in mind, two regular area cannot communicate with each other. So what is the solution here? If I want to make communication possible between 10.1.1 and 40.1.1.1, what I can do?
We can make it as a backbone area only.
Router 2 should be my ABR router.
Yeah.
How I can make router 2 as
Virtual link.
ABR?
Virtual link.
Virtual link. Where is virtual? How? Tell me the process.
I don't know the process, but to connect to the backbone area, we use virtual link.
No, virtual link is used to extend area 0. But here we don't have area 0, na? Virtual link is, let's say if this is here, we have one more router connected with router 4 to router number 5, and this router is, let's say my what? This is in area 0. So router 4 is ABR this scenario. So here we can extend this area. Till here I can create one virtual link between router 2 and router 4. So that router 2 will start acting as ABR router. We will discuss about virtual link later, but here we cannot configure virtual link.
Okay.
Simply I can create one loopback here and I will put that loopback in area 0. Router 2 will become what? ABR router, because now one interface is in area 0 and one interface is in regular area. So router 2 will start acting as
ABR.
ABR. Okay. So two regular area cannot communicate with each other. There should be a backbone area, means area 0 between two regular area. Let me check this scenario is configured or not.
Radhi, can you check record is on or not?
Recording is on. Now I will not forget. Don't worry. Yeah, so configuration is there. Let me check. So IP route OSPF. Am I receiving any prefix? No, I'm not receiving any prefix. So IP OSPF neighbor. So 2.2.2 is neighbor. 2.2.2 is neighbor 3.3.3, 4.4.4. With 2.2.2 neighborship is still two-way. With 3.3.3 neighborship is full because 3.3.3 is BDR and 4.4.4 is DR. Okay. On router number 5, I am not going to access router 2, router 3, right? Let me access router 4, or not required router 4 also, router 5 directly. But routers 1 should have this network, no? Network which is running between router 4 and router 5. So IP interface brief. So, 45.1.1.5 R1. Let me check R1 routing table again. So IP route OSPF. So IP OSPF database. Oh, topology is configured. So IP route OSPF. Why we don't have any route in routing table? So IP route. It is receiving all prefixes. Database router 4.4.4.4. Inside the database we are able to see prefixes, but inside the routing table we are not able to see prefixes. Then I should check filtering here. So IP protocol filtering is not applied here. Everything looks fine. We have some problem here in this topology. Then let me restart the devices. Here also concept is similar, like between two regular area we have one area 0. You guys can configure this topology by yourself. You can see the ABR and ESBR. You can calculate the cost from each router to reach in this 100 network, 70 network, 60 network. So IP route OSPF. configuration is basic. Okay, let me ask some question here. Router 5, this is router 5, this is CLI of router 5. Router 5 have learned these all prefixes in the form of which LSA? Router 5 have learned these prefixes in the form of which LSA?
LSA1. LSA1.
LSA1. Very good. It should be clear to everyone, guys. These all prefixes,
LSA3.
LSA3.
Yes.
And these all prefixes,
LSA5.
LSA5 means from all odd number LSAs, right? And on router number 5, so IP OSPF border router. Router 9 is ASBR router, and router 6 is ABR router. Okay, here just I was wanted to show you something here, but on router number 1 I am not able to see prefixes in routing table. So I think there is some misconfiguration, I think. So IP OSPF database, inside the database everything is, let me access R2. So IP route OSPF, and let me check one more thing here on R4. So IP OSPF interface brief. So both interfaces are in area 10. Router 4 have also installed only 10 prefixes, which router 1 is advertising. So IP OSPF database, inside the database all 60 prefixes are there, 70 prefixes are there, and external prefixes are there. Okay, I think there is some problem in topology. Let me close this topology. Now I will open, one topology where I will we will discuss types of area concept, network type in OSPF. We will discuss filtering, route filtering in this topology. So I'm sending you one snapshot of this topology. Just you need to look up on the topology that where which area exists and how I have designed this topology. I have designed this topology to discuss multiple topics here, right? So you need to be familiar with this topology. Okay, like let me turn on these devices. In this scenario, see here we have area 1, area 2, area 1, area 2. So can router 3 get these prefixes which is running on router number 11? Will router 3 get these network information? If yes, then tell me in the form of which LSA it will get these prefixes. If answer is no, then tell me why.
If you
Because
configure a loop on R9 and
No, loopback is not there.
R3 and R9 directly connected. There is no internal router in area 1,
Backbone router.
backbone router. Yes.
There is no area 0. So R3 is connected with area 1 and area 0. Yes or no? So we can guys extend this area 0 till here also. Means we can create one virtual link between router 3 and router 9. And we will advertise this virtual link in area 0. If we will advertise this virtual link in area 0, then router 9 is virtually connected with area 0. Virtually router 9 is connected with area 0. Then router 9 will become what? APR router. And once router 9 will become AVR router, it will share all prefixes of this area into this area in the form of LSA3. And then router 3 will get these all prefixes. So earlier we were using virtual link. Nowadays we are not using it, but you know, it is important for learning perspective. It is in your syllabus also, right? If anyone is looking for certification, then also you have to learn it. So in next class, maybe we will discuss virtual link in OSPF, and after that we will start type of area in OSPF.
In place of virtual links, what we are using now?
We are not using, we can here configure this area as area 0 also, right? Why we will connect two regular area with each other? We can insert a area 0, or here as I told you that you can create one loopback and you can advertise that loopback in area 0. Because if you want to configure virtual link, you have to learn it, how to configure it, right? And you have to learn like everything so that you can troubleshoot it. So this is one additional command, additional concept. But here by creating one simple loopback, we can make this router as AVR router, and then we can make communication possible between these two area. We don't need to extend it. That's why we are not using, but you can use it. I'm not saying that no one is using, right? Still we are using, but generally we are not using it.
which is better, creating loopback uh, and configuring area 0 or the virtual link?
In rarely you will see two regular area are directly connected with each other. Generally you will see if we are connecting two regular area, that means there are one backbone area. So this is the best and recommendation, that always insert area 0 between two regular area. Why we come up with area concept? Just to reduce the database, right? Because let's say all these routers are in single area, then each router will have lots of number of LSA1, right? And LSA1 carry detailed information of links. So length of database will be lengthy. If we will advertise, if I will put these all routers in single area, that's why we come up with area concept, just to reduce the database so that we can manage it efficiently, more efficiently you can say, right? So whenever we are connecting two regular area, we should insert one area 0. Okay, I think not send this topology. Let me send this topology with you, and you need to just look up this topology once, so that from tomorrow or maybe after 1 hour of tomorrow class, we will come on this topology. We will see the configuration is already there, and then we will learn lots of concept here like area concept, network type, and many more concepts are there. For now, if I will access any router, let's say router 1, I'm going to access router 1 just to check the configuration. Enable show IP OSPF database. So see the size of database of router 1. Still size of database is very large because we have lots of summary LSA. So we will see how to reduce the size of database, how we can reduce these number of summary LSAs, how we can reduce other LSAs. So that's why we have again concept of area inside the area. Actually, till now we understand there are two types of area: backbone area and regular area. These two area are standard area. Now we have some more types of area like NSSA area, stub area. Getting my point? So we will discuss these area to filter LSA. Sometime LSA3, sometime LSA4, sometime LSA5. By default, all routers belongs to a standard area. Or by default, all router belongs to a standard area. And then we have a standard area, stub area, totally stub area, NSSA area, totally NSSA area. We need to understand these all types of area just to filter LSA so that we can reduce the size of database. Right now, router 1 have many LSA, like there are, you can see lots of LSA5. We have some LSA4. This is LSA4, right? It is sharing the information of ESBR router. We have some LSA3, then we have some LSA1. Okay, so topology is already configured, right? We don't need to configure anything like so IP route OSPF. You can see this router is receiving all 60 prefixes, which is running on router number 6. It is receiving all like 100 prefixes, which is running on router number 10. It is receiving all, okay, it is not receiving these external prefixes, right, these prefixes. Why? Because here we need to configure virtual link. Here we need to configure virtual link between router 3 and router 9. That's why router 1 is not receiving these prefixes. So tomorrow maybe we will start this part. Okay, and then finally this router is connected with internet. So here we will see default information originate concept also in OSPF, how we will redistribute default route in OSPF domain. Fine. So we have area 0, area 10, area 1, area 2, EIGRPS number 200, EIGRPS number 100. Let's say in EIGRPS number 100 there are 1000 prefixes. 1000 prefixes are there in EIGRP 100 AS. So now in EIGRP 100 AS we have 1 2 3 4 5 6, around 6 prefixes. So IP OSPF database, inside the database we are able to see external LSA for all 60 prefixes. You can see 460.1.1.0, 60.2.2.0. So if in this domain there are 1000 prefixes, router 1 will have 1000 LSA5 in their database, right? So this time we need to reduce LSA3. We need to read LSA5. Sorry, not LSA3, LSA5. So that's why we come up with area concept. Just I have given overview of area concept in OSPF, like why we come up with OSPF area concept. And tomorrow we will see how these OSPF areas will work, how to configure, and why we need it.
If we summarize the networks in EIGRP, how it will advertise in area 0?
And let's say you are not allowed to access EIGRP router.
No.
Let's say
Reducing the prefix, if we summarize.
If you will summarize the prefixes
in EIGRP,
okay,
what will happen? How
then it will advertise one single prefix. It will advertise summary prefix then, and again router 2 will advertise summary prefix in OSPF domain.
Okay.
But that is not solution. Solution is how to reduce the database. Doesn't matter from where we are receiving the prefixes. how to reduce, how to summarize, like you are summarizing now prefixes, and you will learn how to summarize LSAs. Both are different, yes or no?
Yes.
Okay, so tomorrow we will start this part. Till now we covered all basic things, LSA, all LSAs, neighborship parameter. Yes, now we have advanced concept like area, network type, and filtering in OSPF. Any question from today class, please ask.